Thank you, technical people. All right, let's start from the beginning. Hello, everyone. My name is Danijela Vrzan. Before I became a developer, I was a civil engineer for about 9 years. I just decided to switch, and I absolutely love iOS development today. I am from Croatia. I moved to Toronto about 4 years ago, and I work as an iOS developer at the company called Score. I also write technical articles for Codeco, the previous Revendelig. I also write articles on my personal blog, danielavrzan.com. And because, obviously I have nothing else to do, I will also be a bootcamp mentor at the upcoming Codeco bootcamp, which is super exciting. All right, so today we're going to talk about algorithms and how they can help you improve your code. I want to show you how fun algorithms are and how good they can be for your code. So we're going to start with a practical example. So this is an algorithm I found on LeetCode. If you've never heard about LeetCode, lucky you. So it has a collection of thousands of algorithms. It's a website where you can practice and learn and wonder, why I chose this life. So this is an algorithm called bulb switcher. It has more dislikes than likes. I understand, but no. So I just want to get this out of the way. This is not what we're going to talk about. And we're not going to talk about bulb switchers or how many tennis balls fits into a car or how to pair socks efficiently. We're going to take a look at how we can make our code better by using algorithms that are available and readily for us. So, human brain is a wonderful thing. It starts working the moment you're born and never stops until you stand up to speak in public, honest. Or answering a question during an interview. Something like this, algorithms. Have you ever been asked to invert a binary tree on a whiteboard during an interview? I have. Not fun. And we all make fun of algorithms during interviews, and I could not pass the opportunity to show you this image. Or, maybe you fall into this category, and you can invert binary trees in your sleep. Nice. I mean, we all secretly want to be you, trust me. Or maybe you're like this, and you have no idea what an inverted binary tree is. And that's also OK, because no one knows everything. If you've never had to deal with algorithms, like binary trees or bubble sorts, merge sorts, it's OK to say you don't know them. Something we should all do more. It doesn't mean you're a bad programmer. We don't necessarily all invert binary trees or use bubble sort in our everyday work. And you know why we don't do it? Because there are developers doing it for us. They do it, so then we don't have to. They work for this cool, awesome company you probably heard about somewhere. Yeah, so they invert binary trees and do all of the hard work for us, so we don't have to. What we do get instead are these awesome, ready-to-use APIs all wrapped up nicely in a package, Swift Algorithms package. So let's open the box and let's see what's inside. Ooh, magic? No, it's not magic. Swift Algorithms package is Apple's open source package of sequence and collection algorithms, along with their related types. Now, when I say algorithms, don't expect it to build binary trees for you, right? It was created by Apple engineers to help us improve the code we write every day. If you write a lot of lengthy low loops that can often get difficult to read, it's very likely there is an algorithm in the Swift Algorithms package that you use instead that can help you better. But before these new algorithms get a permanent living address in the Swift standard library, the Swift Algorithms package serves as a playground for them to be tested in the real world by us developers and see if they are valuable enough to be moved into the standard library. Now, the best part here in this sentence is the package is open sourced and it can be found on GitHub, so right here. Apple's open source packages like Swift Algorithms package complement the Swift evolution process so that the engineer working on the standard library can leverage the collective ideas and experiences of developers in the Swift community and engage the community earlier in the development process to improve the Swift development experience. So it's all about us developers to use these packages in our everyday, day-to-day work so we can provide feedback that comes from the real-world users when we use it. And then decisions are being made based on the feedback that we provide. So Swift's standard library already has a collection of built-in algorithms. It takes some time to learn them, but once you do, you'll find yourself using them all the time, pretty much. Algorithms are good for your code, like broccoli. They make your code fast and concise, among other benefits, but I find these two most important. And it's very likely you're already using algorithms in your code today. So let's see how many of them are hiding in the plain sight. Okay, so let's say that we're building a Photos app. It stores a collection of all the photos that we've taken in a collection view. So let's say we're working on a feature in our Photos app to select one or more images so we can do something with them. You might write your code like this. So you create an empty array of selected images to store them. Then you write a for loop to iterate over the index path of the selected items in a collection view. Then we collect all of the images and append them in our new array of selected images. What we're doing here is just transforming the images or mapping them to their index paths. And this is just a map. And map is an algorithm. It makes our code clearer and easier to read, right? It does the same thing as the above for loop, but anyone who reads this line knows that the closure is just transforming the input, no matter the length or the complexity of the code inside the closure. And not only that, an awesome thing about using map is it actually makes the code faster. When we append images to our selected images array in a for loop, the approach requires the array to be dynamically resized as new elements are added to it, which can result in intermediate allocation and slower performance. By using map, we transform the existing array into a new one. The capacity of the resulting array is reserved in advance and avoids immediate allocations and results in faster performance. There might be situations where using a raw for loop is much better. Like, let's not overcomplicate things sometimes. But using map can often lead to more efficient and easily maintainable code and much more readable, and especially if you're working large chunks of data. Okay, so I don't want to just be talking here and hoping you'll believe me. I'm going to show you. I'll prove that using map is really faster. We're going to use this example. It's just an order array of numbers between 1 and 10,000. We also have an empty array called squares that will hold integers. And we're going to iterate over the numbers array and calculate the squares of each and every number and then just append them into the squares array. Nothing too complex. We'll do that using the for loop and then using the map. And we're going to compare how well they both do, and then you'll see. So this is a very small data sample of just like 10,000 numbers. It will serve for the demo purpose, but it's nothing really special. It's not a heavy computation, but it will serve the purpose. Okay, so this is just a small example, a function that we're going to use, iterate over the numbers array, and just square each and every number, append into the new array. I'm going to use this helper method to calculate the elapsed time in seconds, right before and after the function call. It's called cf absolute time get current. And it's going to return the current system absolute time relative to the reference date of January 1st, 2001. You might be asking, why am I using this method to calculate time? Honestly, no particular reason. There are others out there that you can use. It doesn't really matter. This one will serve for this demo purpose. Okay, and then we're just going to print the time. So if I run this in Xcode, so it says the for loop took 0.00079 seconds. We run next time, 847983. Okay, all right. So we can say it took approximately 0.0008 seconds. Nothing dramatic. If that's what you're hoping for, I'm afraid. But this example is quite simple, and it's not really a heavy operation. All right, we're going to do the same thing, only with map. Just map all of the numbers, calculate squares, append to array, same thing. Okay, so map here took 0.0004 seconds. 42, 40, 42. Okay, so approximately 0.0004 seconds. And compared to using a for loop, it's nothing dramatic, I know. I didn't want to use anything complicated, but you can imagine if you're using some very complex computations, which I'm sure there are apps out there that does, using map is really faster. So use map to make your code faster. Use algorithms to make your code faster. Don't stick with the plain old boring row for loop just because you know how it works. That's not to say avoid using for loops, right? Every time you see yourself writing row for loops, just stop and think if that's really what you want to do. Write it using a for loop, make it work, and then optimize and try to use map instead. Or another algorithm that works much better. All right, so we've seen how they can make your code fast. And now we're going to see how they can make your code more concise, more readable. So let's get back a little bit. As we already said, Swift standard library already has a rich collection of built-in algorithms, like map, which we've already seen. But we also have different versions of map, like flat map or compact map. Both are using map in combination with another algorithm. For example, the compact map lets you transform the elements of a collection with a map, but it unwraps all optionals, and any nil values are discarded, which we filter out with filter. It's a combination of these two algorithms. Developers have used this combination so often that Apple developers decided to create a new algorithm for it, which combines the two, and there become compact map. And then we also have a flat map, for example, which transforms an array with a map, but in some scenarios can produce an array of arrays, which might not be what we want. So we use joined to join it all into one array. We flatten the sequence. Pretty cool, right? You're able to chain the algorithms together to create more powerful ones. And these are just a few examples, right? Ooh. No? Oh, okay. I'm like Daniel now. Okay, let's get back to our Photos app. We've been working on this app, and it's going pretty well, right? But now we've decided we also want to be able to store videos as well, not just images. And we want to add a new feature when the user taps on the video. We want to show a quick preview of 5 latest videos. We're going to store the videos in an array. So we loop over the items in our media collection in reverse because we want to get only the last 5 items. We check the item and make sure it's a video and append it to the array. And finally, we stop when we get 5 videos. It's not that bad, but it's quite a lot of code for a simple operation. If I quickly show you this code and just move it away, you might not catch immediately what was going on there, maybe. So we're going to rewrite this code to make it more concise by chaining together algorithms from the standard library that we already have in the code. Okay, so it's this. It's much better than what we had. It's doing the same thing. We're getting the reversed, we're compact mapping, making sure it's a video, prefix of 5 items. It's so much better. Okay, there is an issue with this code. Xcode will throw you an error because Xcode. Cannot assign value of type something something. Okay, why did not I think of that? The solution is actually quite simple. We're trying to store a slice of a reverse collection of an array of videos into an array, right? Actually, we just need to wrap it into an array because prefix, it does not return us an array. It's using something else, so it can be more optimized. Just wrap it into an array, and that's it. Okay, much better than what we used to have, right? There you go. So use algorithms to make your code more concise. Now let's go back to our cool app. We're going to build a new feature. We want to group or sort our media items, both photos and videos, into a collection, separated by month. So all photos and videos I took in July last month will have a title of July and be grouped there. Because our app can store both videos and photos, which we call media, to refer to both types, we want to map all our media items together. If I use map, I could end up with an array of arrays, which is not what I want. So I'm going to use flat map. All right. Now, how do we get the months? Every media element has a date associated with it, the day the photo or a video was taken, right? I'm going to use an algorithm for this from the Swift algorithms package. But first, I need to import it. So if you go to Xcode and to import the packages, the Swift algorithms package is right at the top. So you just import it into your project, import algorithms. And now we can work with some cool algorithms from the package. So let's take a look. But first, let's see let's visualize what we want to do here. I'm a visual person. The idea is to group our elements based on the day they were taken, so specifically by month. So something like this. Now I just want to, they are all a single array, but I want to group them by month, so July and August. Okay, so let's check what are we working with here, right? Let's take a look at the documentation. I've calculated recently, and I think there are about 44 algorithms in the Swift algorithms package, which is quite a lot. There are different versions of some algorithms, but it's pretty cool. So if you want to play around with it, there's a lot of algorithms to check out, and a lot of them are actually pretty cool. Okay, so after some reading through, there are a lot of them. They're grouped. The documentation is actually pretty good. Now I think I found exactly what I want. There's an algorithm called chunked. Full disclosure, you're going to hear chunked quite a lot. So let's take a look what it does. It breaks a collection into subsequences or groups. I have to say the documentation is really great, unlike some. You can see the detailed design and how it all works behind the scenes if you're interested. Chunk has a few different methods, so let's see which one suits our needs the best. So there is chunks of count. It separates a collection into subsequences by defining a size of the group. So if I define it like a size of 3, let's see what it does for us. So it grouped June, July, because we told it to group into counts of 3, but this is not really what we want, right? Because I have no idea how many pictures I took in June or July or August, might be hundreds, might be 0. So I cannot really give it a specific number. Okay, let's take a look at the next one. So there is one called chunked by. It gives us an option to define a custom predicate to test consecutive elements and then create subsequences where the predicate is satisfied. Okay, this looks promising. Let's see if it does what we want it to. So every element in our collection has a reference to the date it was taken, and we want to group our elements by month. If the element's month is the same as the current value we're comparing with, it should be grouped with that element. If it doesn't, we start a new chunk with the new element and use its month as the comparison value. All right, this looks much better. This is exactly what we want in our code. We want to group our elements by month. What's also great about chunked is it preserves each element in its initial ordering. If you join the collection after chunked, you're just going to get the original collection as it was. It's also important to note that the collection has to be sorted, obviously, for the chunk to do its magic. In the case of our app, the collection is already sorted by date and month of the picture or video was taken. But if in your case it was not sorted, you will have to first sort your collection. All right, so we're not going to implement it in our app. So if you remember, we used a flat map to make an array of media elements. Let's import algorithms and chunk on the month by comparing every consecutive item's date. When we get to an element that has a different month than the previous element we were comparing with, we chunk the elements there. And then we get the next month, and that's how we do the entire collection. Cool, right? Ooh, yes. Okay, so we have our chunks, but now we need to get the months. To separate the chunks and then join it all together into a single collection, because I want to have a separation. I want to have the month in there in the collection. Well, there are different ways you can approach the solution here, absolutely. I'm really liking this Swift algorithms package, so I'm going to see if there's another one that can help me out here. I know they're joined already in the standard library, but that doesn't help me, as it's just going to reverse the chunk together, right, as we already said, and we're back at square one. I want to join these chunks together, but I want it to be separated by month. Luckily, Swift algorithms to the rescue. There is another algorithm here called join, but it's another version of join. It gives me an option to give it a separator, and I can use a predicate. So I'm just going to use the predicate. I'm going to take the first element of a chunk, get its month, and just put it back. And that's how I'm going to separate my collection and just join it again into a single collection. So let's add it into our code. Of course, thank you, Xcode. Now, unlike most of Xcode errors, this one actually makes sense. Chunked returns our array as an array slice type. An array slice type is a fast and efficient to perform operations on sections of large data. It has the same interface as an array, and you can generally perform the same operation as you can on the array, but it's not an array. And if you try to use this in your view code, it's going to complain. So join here returns us a flattened sequence of an array slice of our media element. Same thing pretty much, we just have to convert it all into an array and save the collection. And not only that, to make sure this gets computed on demand only, just add lazy in front of it. You're not fun. Aren't algorithms fun? They make your code faster, more readable, and just better. It saves you hours of writing your own custom logic, and especially when working with dates. Like, nobody likes to work with dates, right? They're much, much easier. They are readily available for us. Apple engineers have did a lot of work to put those algorithms out there for us, and nobody wants to work with algorithms, right? So just go out there, use these algorithms, and you'll see how good they are. And if we use them enough, then Apple will put them into standard library, and that's even better. Okay, so if you want to learn more, of course, no better way than to check out the WWDC21 official video, Meet the Swift Algorithms and Collections Packages. Absolutely awesome. Paul Hudson has also created a video and also an article where you can read more. I think he wrote about like 7 of his favorite algorithms, gave examples of each. Really good video. Sean Allen actually created a video about 2 weeks ago on Swift algorithms and how he implemented chunk in his own app that he's making. So make sure to see that one as well. It's really good. And one more thing. So if you remember at the beginning, I mentioned how algorithms can help you pair your socks efficiently. Well, I found this on Stack Overflow. I swear, completely by accident. It's a question from a computer scientist who was doing laundry one day and figured out he wasn't very efficient. So this is about 10 years old, but people are still pitching with their ideas. The most upvoted answer suggests hashing as the best approach and doing recursion. I mean, don't over-engineer a simple solution. Just pair the socks, go have some fun. Me, however, I found the most efficient ways to delegate. And so I delegated to my husband. Proven efficiency. Thank you so much.